I want you to close your eyes for a second and just picture this. It's not just a few animals wandering around. It's an entire population. We're talking millions, moving with perfect synchronization across whole continents.
Right.
And they're guided purely by some deep internal force, thousands of miles through air, land, sea, all on instinct.
And with a precision that, as you said, rivals our best GPS. It's an incredible image.
It really is.
And that's exactly what animal migration is at its core. It's this large-scale, usually seasonal movement of whole populations, and it's all in direct response to, predictable ecological changes.
Following the resources.
Exactly. It's so much more than just an annual event. It's really nature's ultimate expression of rhythm and resilience. We often think of these movements as the literal veins and arteries of our Earth.
Pumping life across the globe.
Yes. Pumping life and nutrients across these vast distances.
At a perfect metaphor. And that's really our mission for this deep dive. We want to unpack the astonishing science behind these movements, understand the rules of the road, and also reveal some of the really urgent threats they're facing today. We've pulled together sources on 5 truly superlative migrations, the planet's wildest, longest, and most mysterious treks.
And to start, I think we really need to clarify what makes a true migration.
Okay.
Because we're talking about these highly programmed population movements. It's not simple dispersal like, say, plankton just drifting on the currents.
Or animals just spreading out from where they were born.
Right. And it's also different from nomadism. So take the American bison. They wander, they follow food, but they don't have a fixed repeating range. Migration is different. It's a significant population shift responding to specific conditions, often on a very predictable cyclical schedule.
So programmed journey, not just wandering for food.
Precisely. And the real mind-bender here is the navigation. I mean, how do these creatures, from tiny insects to massive whales, orient themselves? How do they travel thousands of miles, often over a featureless ocean with no map? Where is this ancient compass?
The idea that instinct alone can guide a creature from the Arctic all the way to the Antarctic it's almost unbelievable.
It is, but it's rooted in this incredibly sophisticated array of multisensory systems. They actually combine several environmental cues at once.
Like what?
The most common ones involve the positions of the sun and stars, which, fascinatingly, means they need an intrinsic clock sense to compensate for the movement of the sky.
Of course.
They also use the Earth's magnetic fields, detecting really subtle changes in both the intensity and the angle of the field.
Okay, hold on. I want to linger on the magnetic field. You're saying they have an internal GPS that's detecting changes in the planet's energy field?
They do. In many species turtles, some birds, they have magnetic particles in the brain or specialized cells in their eyes that act as magnetoreceptors.
Wow.
And beyond that, they use atmospheric cues. They can sense changes in UV light polarization, tiny variations in air pressure, and even infrasounds.
Infrasounds.
Yeah, very low-frequency sounds that travel huge distances. It might help them map out mountain ranges or distant wave patterns from hundreds of miles away.
So it's a dynamic, multisensory map built on celestial, magnetic, and auditory data. But is it all just hardwired instinct, or is there any learning involved?
That's the key question. It's an interaction. Instinct lays the foundation. It gives them the basic direction. But research clearly shows that navigation gets refined over time.
So they get better at it.
They get much better. The classic example is the white stork. Young birds on their first trip, they often explore these new, longer, slower routes. But when those same storks come back as mature adults, they take shortcuts. They use that acquired knowledge to be quicker and more direct. The older the traveler, the more efficient the route.
Experience fine-tunes the inherited map. That makes perfect sense. All right, let's start our journey with maybe the most famous terrestrial spectacle of all, the Great Migration.
Ah, the Serengeti. The scale here is it's why it's so iconic. You're looking at 2 million animals in constant motion.
Too much.
The core is about 1.5 million wildebeests, but then you add 500,000 zebra, 200,000 Thompson's gazelle, maybe 18,000 eland. It's a single thundering organism on a ceaseless circular pilgrimage.
And covering up to 1,000 miles every year.
Every single year, and that cycle isn't random. It's dictated entirely by the seasonal rains. They are perpetually following the fresh grasses that spring up after a storm. It ensures they always have the best grazing and enough water.
So this movement, it's not just for them, it's for the whole ecosystem.
It is indispensable. It circulates nutrients, it prevents overgrazing, and it underpins the vast predator populations that rely on them.
Right, but if the goal is just fresh grass, Why do they take the huge risk of concentrating in one spot for calving season? What's the trade-off?
That concentration is a tactic. It's about safety and synchronization. Calving season, which is usually January to March, is deliberately timed. The herds all gather in the southern Serengeti on the Ndutu Plains.
And the intensity is just off the charts.
It's astonishing. Over 80% of the fertile females drop their calves within just 2 to 3 weeks. That's up to 500,000 newborns hitting the ground almost at the same time.
Safety in numbers, even against the world's most concentrated group of predators.
Exactly. I mean, yes, the concentration of vulnerable prey attracts a massive concentration of lions, cheetahs, hyenas, but the sheer volume of newborns means the predation rate per calf is actually lower. They overwhelm the predators with too many targets at once.
And then, of course, the part everyone knows about, the river crossings.
That comes later in the cycle, usually July through October. The dry season pushes them north, and it all culminates in these treacherous crossings, like at the Mara River.
And this is a truly high-stakes moment.
Absolutely. They're facing fast, powerful currents, steep banks, and some of the largest, most ancient crocodiles in Africa just lying in wait. The drama, the sheer volume of animals trying to cross at once, it's unforgettable and so iconic that, you often have to book accommodations a year in advance to see it.
It's amazing that this has been running like clockwork for millennia. Okay, let's shift scales completely. From terrestrial megafauna to a creature that can fit in your palm, but navigates a journey that feels biologically impossible.
The monarch butterfly.
The monarch butterfly.
It is a true biological paradox. It's the only butterfly we know of that makes a long, two-way seasonal migration, up to 3,000 miles. But the real miracle, the thing that makes it so profound, is that the trip takes longer than a single butterfly's lifespan.
Explain that relay race again, because that's where the mystery really is.
Okay, so the journey north from Mexico takes up to 4 successive generations. The first 3 live for only 2 to 6 weeks. Their whole job is just to complete one leg of the journey, lay eggs on milkweed, and then die.
A true relay.
A true relay. But it's the final 4th generation, we call it the Methuselah generation, that emerges in late summer. Hormonal changes put them in a state of reproductive diapause, which extends their life to nearly 9 months.
And that's long enough to fly the entire distance back south.
The entire way. And here's the kicker. They fly back to the exact spot their great-grandparents left, a place they have never, ever seen before. That navigational map is entirely inherited.
Which is the unsolved mystery.
It is. They've never been within thousands of miles of this destination, yet they navigate en masse to the exact same Oyamel fir forests in central Mexico, clustering at nearly 10,000 feet.
How do we think they do it?
The research suggests their tiny brains combine a magnetic compass with a really sophisticated, time-compensated solar compass. It's inherited knowledge of a specific route, which puts their complexity right on par with, much larger birds and whales.
An incredible feat. But this is a species that's facing a really urgent crisis right now.
They are. The migratory monarch is now listed as endangered on the IUCN Red List. We're seeing a massive population collapse.
And it's driven by a few key factors.
Primarily 3. First, the widespread loss of milkweed, their breeding habitat in the U.S. and Canada due to herbicide use. Second is the loss of that critical overwintering habitat in Mexico from illegal logging.
And why is that specific high-altitude forest so critical?
That Oyamel fir canopy provides a very specific microclimate. It's like a thermal blanket. It gives them the cool temperatures they need to slow their metabolism, but also enough humidity so they don't dry out. Without that canopy, they're exposed to killing freezes or drying winds.
And the final threat.
The final threat is climate decoupling.
That's a great term. What does ecological decoupling actually mean for the monarch?
It means the timing is all wrong. Global warming is causing erratic weather, which can delay when milkweed emerges or cause it to dry out too early. If the butterflies arrive before the milkweed, the only food for their larvae is ready, the relay race it breaks down. The generations can't continue the journey.
That link between timing and survival is a powerful point. Let's dive into the ocean now and look at some extremes. First, the gray whale, the mammalian marathoner.
The gray whale undertakes one of the longest annual migrations of any mammal. It's an astounding 10 to 14,000 miles round trip. They journey from their summer Arctic feeding grounds, where they just gorge on tiny amphipods, all the way down to the warm, sheltered breeding lagoons of Baja California.
They're creatures of schedule, which is why this new crisis is so alarming.
It is. The eastern North Pacific population has roughly halved since 2016.
Halved.
Halved. It's a dramatic decline. and it led to a formal declaration of an unusual mortality event, or a UME. And scientists are pretty certain it's linked to warming ocean temperatures, causing a fundamental breakdown in the food chain.
So they get to the Arctic and the food just isn't there.
Or it's not accessible. The nutrient-rich organisms they rely on are disappearing, and it's leading to massive starvation. The food source they travel 7,000 miles for is no longer guaranteed.
A brutal consequence. But if we're talking pure distance, nothing. Nothing beats the Arctic tern.
Nothing. This bird flies further than most of us drive in 5 years, every single year.
It's an insane frequent flyer program.
It holds the absolute record. These small birds zigzag between the Arctic and the Antarctic for an average round trip of over 55,000 miles.
55,000.
In its lifetime, an individual might fly the equivalent of 66 times around the Earth. Their strategy is brilliant. They just follow the summer, maximizing their daylight hours for foraging.
Okay, let's forget distance for a second. What about the largest daily movement on the entire planet by sheer mass? I hear that record belongs to something a bit less glamorous.
It does. It's called the dual vertical migration, and it is the world's largest animal movement by total biomass. Every night, millions upon millions of tiny zooplankton, krill, and small fish rise from the deep ocean to feed near the surface.
How far up?
Anywhere from 300 to 3,000 feet, every single night.
So why the daily commute?
It's all about predator avoidance. They rise at dusk under the cover of darkness to feast, and then they sink back down at dawn to hide in the deep, lightless zones from visual hunters. And because this happens over, 3/4 of the planet's surface, the total weight of creatures moving up and down daily just dwarfs any other migration.
Amazing.
Yeah.
Now, moving from the cyclical to the unpredictable, let's talk about the sardine run off South Africa. This isn't a guaranteed event like the wildebeest, is it?
No, not at all. It's what we call a massive seasonal eruption. It's irregular, it's non-cyclical, and it's all driven by very specific short-term ocean conditions.
Warm conditions.
It's dependent on a cold water upwelling. The water temperature has to be at or below 19 degrees Celsius. If it's too warm, the millions of sardines just stay offshore. The run doesn't happen.
But when conditions are right,
Yeah.
it's one of the great feeding frenzies of the world.
It's unparalleled. You get thousands of predators, dolphins, sharks, bride's whales, massive flocks of Cape gannets, all working together with coordinated precision. The dolphins herd the sardines into these tight, panicked bait balls near the surface.
And the gannets are particularly spectacular, I've heard.
They dive like torpedoes. They can hit depths of 30 to 40 meters to catch a fish.
So viewing this must be a really strenuous expedition. You'd need pinpoint accuracy to even find the shoals.
Oh, absolutely. The shoals are fast-moving, they're unpredictable. Responsible operators, they rely heavily on expert tracking. They'll use the birds as a clue, but critically, they often use microlight aircraft pilots to scout the coastline.
So a spotter in the sky guides the boats.
In real time, it's truly hunting for the spectacle.
Let's quickly mention two other incredible spectacles. We have the largest mammal migration by sheer number, the straw-colored fruit bats in Zambia.
Yes, up to 10 million bats. They arrive in this synchronized swarm to feed on wild fruit right after the first rains. It completely dwarfs every other mammal movement in just the sheer count.
And then the Christmas Island red crab migration, which really highlights how precise nature's internal clock can be.
It's astonishingly complex. They have a dual timing mechanism. The march itself is triggered by the first substantial rainfall of the wet season.
Okay.
But the final spawning, that has to happen at a hyper-specific moment before dawn on a receding high tide during the last quarter of the moon.
Why that exact combination?
The receding tide minimizes the distance the eggs have to travel through the rough surf, giving the larvae the best chance to be swept out to sea without being destroyed. It's an evolutionary necessity.
But this localized miracle is facing a very acute danger.
It is. The invasive yellow crazy ant. It forms these massive supercolonies and preys directly on the adult crabs, threatening this keystone species on the island.
So if we connect all these stories, from the 2 million strong herd to the single monarch's inherited map, the bigger picture is, well, it's pretty clear. The shadow of the Anthropocene is undeniable.
It is. Nearly half of all migratory species that we know need protection are currently experiencing declining populations, and it's driven by human-caused factors.
The problem is that these migrations rely on entire seamless corridors, and we're fracturing them.
We are. The two biggest problems, as we've seen, are physical interruption and timing disruption.
So that interruption, habitat fragmentation.
Right. Infrastructure, roads, rail lines, fences, they physically block ancient routes. Think of caribou in the Arctic trying to navigate industrial development. Or, on a smaller scale, how dams completely thwart fish migration, stopping salmon from ever reaching their spawning grounds. It just breaks the cycle.
And the other threat is that timing disruption, the ecological decoupling we talked about with the monarchs.
Exactly. Global warming is altering the timing of everything. A baleen whale might shift its schedule based on water temperature, but the krill it eats might shift based on light. You get a mismatch. If the food doesn't arrive when the feeder does, the whole ecosystem can starve. That loss of synchronization is probably the most insidious risk of all.
So what does this all mean for us? The fate of these migrations, it hinges on more than just protecting an isolated park here or a breeding lagoon there.
The mandate has to be the protection of entire interconnected ecological corridors. We have to see the journey, not just the destinations, as sacred. For anyone listening, supporting organizations and professional tourism operators who are committed to sustainable funding and minimal impact practices. That's essential. It helps maintain those corridors and keeps the lifeblood of the planet flowing.
It's just incredible to think about the inherited, dynamic, multi-sensory knowledge that guides these travelers. If a creature as small as a monarch butterfly, which spans its epic 3,000-mile migration across 4 successive generations, can inherit a route it has never seen, what hidden maps, what deep instincts might we humans carry within us that we have yet to explore? What knowledge are you driven to seek out, even if you don't yet know the final destination?